Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Europa, the hidden ocean world that keeps refusing to stay quiet. If you point a telescope at Jupiter right now, you'll see 4 tiny dots shifting around it. Nothing dramatic at first glance. Just another quiet corner of the night sky. But one of those dots might be hiding one of the strangest secrets in the entire solar system. Not a volcano. Not a chunk of rock. Not a leftover fragment of gas or dust. Something far more unsettling. An entire ocean. The catch is simple: you will never see it directly. Because it's buried under tens of kilometers of ice, like a world sealed inside a frozen vault. And here's where things get even stranger. Scientists are now seriously asking whether it's not just water down there, but something that might still be active inside. But before any excitement kicks in, there's a twist most people forget. For a very long time, we didn't even know what this object really was. In fact, for centuries, it was just another faint point of light in the background of the solar system. Back in 1610, Galileo turned his telescope toward Jupiter for the first time and noticed 4 small lights moving around it. What he was actually seeing were moons. Later, we gave them names. One of them was Europa. At the time, though, it didn't matter. No name, no identity, no storyline, just a moving dot in a notebook sketch. And honestly, in the early days, nobody thought much of it. As the old saying goes, out of sight, out of mind. Galileo himself was focused on something much bigger, the realization that not everything revolves around Earth. The moons were just supporting evidence. Europa? It was barely a footnote. For a long time after that, nothing really changed. In the 18th and 19th centuries, astronomers mostly just refined its orbit. More precise numbers, better calculations, same basic indifference. By the mid-1800s, John Herschel helped standardize naming, and the moon finally got a proper identity, Europa, named after the mythological figure. It sounded poetic, but in reality, it was still just described as a small, cold object orbiting Jupiter. No surface details, no features, no reason to care beyond orbital mechanics. It was the kind of object that sat quietly in the back of the classroom of astronomy, present, but never called on, until the space age arrived. In the 1970s, NASA began sending probes into the outer solar system. Pioneer 10 and 11 were the first to pass through the Jupiter system. Their data wasn't sharp, but it raised an eyebrow. Europa was unusually bright. Too bright for bare rock. More like ice. Still, nobody wanted to jump to conclusions. In science, brightness is a clue, not proof. The real shock came in 1979, when Voyager 1 and 2 flew past Jupiter and returned the first detailed images of Europa's surface. And then something awkward happened in the control rooms: silence. Because the images didn't make sense. No real craters. A strangely smooth surface. And everywhere long cracks stretching across the ice. Normally, an old celestial body should be scarred by impacts. But Europa looked almost refreshed. Which raised a brutal question: if it's being reset, what is doing the resetting? Ice doesn't heal itself. Rock doesn't erase its own scars. As one scientist joked, it looked like someone was regularly cleaning the surface. Nobody believed in a literal someone, of course. But the idea that something was actively reshaping the moon started to creep in. From that point on, Europa stopped being just a dot. It became a question mark. And Voyager had only scratched the surface. The real turning point came with Galileo in the 1990s. Once it entered Jupiter's orbit in 1995, it began multiple close flybys of Europa. And that's when things started getting weird. The magnetic field around Europa wasn't behaving normally. It was fluctuating in a pattern, as if something inside was interfering with Jupiter's enormous magnetic environment. First reaction from the team: instrument error. That's standard procedure in science. When reality looks wrong, assume the machine is wrong first. They recalibrated, measured again. Same result. Tried different models. Same result. Eventually, they had to accept an uncomfortable possibility: the data was real, and they didn't know how to explain it. So a new idea emerged. Under the ice, there might be a conductive layer. And in planetary science, the most common conductive liquid is simple, salty water. That's how the model of a global subsurface ocean began to form. Not a small pocket, not isolated lakes. A planet-wide ocean wrapped around the entire moon. At the time, that idea felt almost too extreme, because it quietly rewrote what Europa was supposed to be. A frozen, dead world suddenly looked like something very different, something that might not be dead at all. Still, scientists didn't celebrate. The wording stayed cautious, consistent with a conductive layer and possible liquid water. In other words, it looks like an ocean, but we can't officially call it one. And from there, Europa's identity began to shift. From icy rock to potential ocean world. But the story didn't stop there, because the next clues would push the question even further. If there really is an ocean down there, the real question becomes, is anything moving inside it? Voyager didn't fly past Jupiter with the intention of rewriting science textbooks. It was never supposed to be revolutionary. Just a quiet mission in 1979, take some pictures, collect data, and figure out what the outer gas giant system actually looks like. Voyager 1 arrived in March, Voyager 2 followed in July. Simple plan, simple goals. But as the old saying goes, the devil is in the details. And the details were anything but simple. When the first clear images of Europa came back, the room fell into a kind of quiet confusion. Scientists expected what you'd normally see on an ancient world: craters, scars, a surface battered by billions of years of impacts. Instead, they found almost none. Europa looked too clean, almost unnaturally so. Large areas seemed smoothed out, as if something had erased its history. Later analysis introduced a term for this: resurfacing. In other words, the surface might not be ancient and static at all, it might be actively renewed. But in 1979, scientists didn't dare say that directly. The safer assumption was slow-moving ice. Still, that raised an uncomfortable question: can ice somehow heal itself? And then things got even stranger. Voyager images revealed long, crisscrossing fractures across the surface. Massive icy cracks stretching for hundreds of kilometers. Scientists later called them lineae. If you saw them on Earth, they wouldn't look like normal geology. They would look like something broken, reassembled, and broken again. One researcher joked that Europa looked like a room forced to be cleaned every day, but nobody admits who's doing it. Funny on the surface, but unsettling underneath. Because if impacts weren't carving those patterns, what was? Even more importantly, Voyager data hinted that Europa's interior might be far more active than its frozen exterior suggested. But back then, that was still just speculation. Scientists weren't ready to cross the line into something is happening under the ice. So Europa ended up in a strange state, not dead, but not proven alive either. Stuck in limbo, between a rock and a hard place, as the saying goes. And it stayed that way until the next mission arrived. In 1995, NASA's Galileo spacecraft entered Jupiter's orbit. This time, the mission was closer, more precise, and far more persistent. From 1996 onward, it repeatedly flew past Europa, trying to understand what that ice shell really was. Then the data started behaving badly. Galileo's magnetometer picked up something unusual near Europa, a changing magnetic signal, but not random, structured, almost rhythmic. As if something inside the moon was interacting with Jupiter's powerful magnetic field. The first reaction was textbook science: the instrument must be wrong. So they recalibrated, checked everything, ran new models. Same result, again and again. At some point, the uncomfortable conclusion became unavoidable: the data was real. And the simplest explanation pointed to something unexpected beneath the ice: a conductive layer. In physics, that usually means one thing: liquid. On Europa, the most likely candidate is salty water. That's how the idea of a global subsurface ocean began to take shape. Not a pocket of water, not scattered lakes, but a continuous ocean wrapping around the entire moon beneath the ice shell. The reaction from the scientific community was cautious, not celebratory. Not because it wasn't exciting, but because it sounded almost too extreme to accept immediately. A 3,100-kilometer white ice moon potentially hiding a global ocean world underneath? That's not a small revision. That's a rewrite. Still, Galileo wasn't finished. It also revealed something called magnetic induction effects. When Jupiter's magnetic field sweeps past Europa, the response looks like it's interacting with a conducting sphere. That behavior, studied in later research, strongly supports the idea of a global, electrically active liquid layer. In other words, not just maybe water, but possibly a connected, planet-wide ocean. At that point, the scientific tone shifted from, "that seems unlikely," to, "okay, that might actually fit," to, "we need more data." But the most important shift came quietly at the end of that chain of evidence. Because once the signals piled up, researchers realized something simple but powerful: if there is no ocean, then something else has to explain all of this. And nothing else fit. So the questions started repeating themselves. If there is an ocean, where is it? Beneath the ice. How thick is the ice? Nobody knows. How deep is the ocean? Nobody knows. Could there be life? That answer is even further out of reach. But from 1995 onward, Europa stopped being just a faint dot from Voyager images. It became a recurring problem in planetary science, not because it looked special, but because the data kept refusing to let it be ordinary. It looks less like a dead ice ball, and more like a sealed system. A world you suspect is active inside, but haven't been able to open yet. And the real tension now is this: if that ocean truly exists, it may not just exist quietly. Something might actually be happening down there. As Galileo's data kept piling up, scientists slowly started taking a much bolder idea seriously. Not just there might be a bit of water under the ice, but something far more extreme: a complete global ocean. At first, it almost sounded unreasonable. After all, Europa is far from the Sun, about 680 million kilometers away. It receives roughly 25 times less sunlight than Earth. By all logic, it should be nothing more than a frozen, lifeless ice ball. But as the old saying goes, things aren't always what they seem. And Europa was already breaking expectations. Voyager and Galileo together pointed to the same strange conclusion: the surface wasn't stable. It was being reshaped again and again, as if something underneath was constantly resetting it. So scientists started working backwards: if the surface is changing, what's happening inside? By the 1990s, a clearer picture began to form: a three-layer structure. Ice on top, a liquid ocean in the middle, a rocky core below. Simple on paper. But the middle layer changed everything, because this wasn't just a pocket of trapped water. The more the models improved, the more one idea stood out: this could be a global ocean, wrapping around the entire moon. Not Earth-like oceans on a surface, but something closer to this: the whole world is ocean, covered by a shell of ice. By the late 1990s, NASA studies and reanalyses of Galileo data increasingly supported this view. Depending on assumptions, that ocean could be tens of kilometers deep or even over 100 kilometers. At the upper end, the total volume becomes almost hard to picture, potentially 2 to 3 times all of Earth's oceans combined. No wonder a bit of humor started circulating in science circles: Earth has oceans. Europa might just be hiding its. But there was another twist: it likely wasn't pure water. Scientists strongly suspect it's salty. Without salt, the electrical signals Galileo detected in Europa's magnetic environment simply wouldn't make sense. And salt water has a crucial advantage: it can stay liquid under extreme cold and pressure. Still, a big problem remained. If it's so far from the Sun, why hasn't it frozen solid? That's where a key idea comes in: the ice shell isn't static. Voyager images showed cracked, shifted blocks like a frozen jigsaw puzzle that had slowly moved apart. So scientists proposed ice shell convection: the ice slowly circulates, cold on top, warmer below, slowly rising and sinking over time. Like thick syrup moving in a gigantic pot, except the pot is a moon. But even that wasn't enough. One question still remained unanswered: where does the heat come from? Because without a steady energy source, the ocean should have frozen long ago. The answer lies in one of the most important mechanisms in the whole system: tidal heating. Europa doesn't orbit Jupiter in a perfect circle, it follows a slightly stretched, elliptical path. That means its distance from Jupiter constantly changes. Closer in, gravity pulls harder. Farther out, it relaxes. So Europa is constantly being stretched and released, over and over again like a cosmic stress test. Each cycle creates internal friction, and friction creates heat. Heat trapped beneath the ice. But the story gets even more intense. Europa isn't alone. It's locked in orbital resonance with Io and Ganymede, two other moons of Jupiter. In simple terms, their orbits are synchronized like a cosmic rhythm. Io orbits once, Europa twice, Ganymede about 4 times. This gravitational beat keeps pulling Europa's orbit out of shape again and again. The result? The deformation never fully stops. Internal friction is constantly reinforced. Heat is continuously pumped into the system. In other words, Europa isn't just occasionally warmed, it's being steadily kneaded by gravity itself. As one scientist joked, it's not a moon, it's cosmic dough being constantly worked over. And as funny as that sounds, the physics is crucial. Because tidal heating explains 3 major mysteries at once: why the ice hasn't fully frozen, why a liquid ocean could exist, and how the system can remain stable for billions of years. But even then, scientists weren't satisfied. Because another deeper question emerged: if there really is an ocean, what is it like? Is it a quiet, stagnant layer? A kind of frozen sea beneath the ice? Or is it dynamic, circulating, active, maybe even geologically alive in its own way? In the Galileo era, there was still no answer. Only one conclusion was becoming clear: this world was far more complex than anyone had imagined. And the strangest part might still be ahead. At this point, Europa's story stops feeling like a science report and starts feeling more like a slow-burn mystery that keeps escalating. Because just when scientists had begun to accept the idea of a hidden ocean under the ice, new clues started coming in from a completely different direction. In the 2010s, the Hubble Space Telescope began repeatedly observing Europa in ultraviolet light, and something odd showed up. On certain passes, there were brief, localized flashes near its edge, short-lived anomalies that appeared and disappeared. Not constant, not predictable, more like a distant light flickering in the dark for a second, then gone. As the old saying goes, once is chance, twice is coincidence, and by 2012, researchers started paying serious attention. One possible explanation stood out: water plumes, jets of vapor or tiny ice particles erupting from beneath the surface, like geysers punching through the ice shell. If that's real, the implications are huge. It would mean we don't need to drill through tens of kilometers of ice. We could simply fly through one of these plumes and sample the material directly. At NASA, someone jokingly summed it up as, "We're not exploring a planet anymore, we're waiting for it to open itself." But here's the catch: the data was inconsistent. Some observations saw it, others didn't. And in science, inconsistency is a red flag. So Europa stayed in this uncomfortable state. It looks like something is there, but we can't confirm it yet. Then, around 2018, another twist arrived. Researchers went back to old Galileo data from the 1990s, data that had once seemed unremarkable. But with modern models, one team found something intriguing: a brief plasma disturbance recorded during a flyby that could match the signature of a plume crossing the spacecraft's path. In other words, we might have already flown through one of these jets decades ago, without realizing it. If true, plumes wouldn't be a rare modern discovery, they'd be a repeating feature across missions. Still, the scientific community stayed cautious. Because in planetary science, looks right is not the same as is proven. So Europa entered a very strange phase, like a room where you can clearly hear a sound inside, but the door is still locked. You know something might be there, but you can't see it yet. And in that half-confirmed space, the biggest question naturally rose to the surface: if there's an ocean, if there's energy, if there are plumes, could there be life? From there, the story shifts into the most sensitive territory. When scientists talk about life on Europa, they don't start with aliens. They start with 3 basic ingredients: liquid water, an energy source, and chemistry. And Europa quietly checks all 3 boxes in a way that feels almost unsettling. A likely global ocean of liquid water, continuous energy from tidal heating, and a chemically active surface constantly bombarded by radiation, possibly interacting with a rocky interior. Then scientists look back at Earth and find an unexpected comparison: deep-sea hydrothermal vent ecosystems. On the ocean floor, in total darkness, life still thrives without sunlight. No photosynthesis, no solar energy, just chemical energy, what we call chemosynthetic life. And suddenly, Europa doesn't feel so alien in concept. The structure starts to rhyme. So a bold idea appears: if Europa's ocean floor has hydrothermal activity, then it could, in theory, support a completely independent biosphere, maybe even more stable in some ways than Earth's deep oceans. As one scientist put it jokingly, if there are fish down there, they probably don't even know what the sun is. Because in that world, the sun never mattered. But here's the hard truth. So far, we have no direct evidence of life. No confirmed biosignatures. No clear organic structures. No repeatable detection of biology. Only indirect conditions that could support it. And that puts Europa in a very uncomfortable middle ground. It doesn't look lifeless, but it's nowhere near confirmed as alive either. Then the question flips. If we haven't found anything yet, what does that actually mean? Maybe it doesn't mean absence. Maybe it means we still haven't really seen the place properly. And so the list of unknowns grows instead of shrinking. How thick is the ice shell? Just a few kilometers, or dozens? Is the ocean uniform, or layered and chaotic? Are the plumes real and stable, or just rare events? Even the ocean's chemistry is still largely inferred. After decades of study, the most honest conclusion is almost ironic. The one thing we're truly confident about is that Europa might have an ocean. But that uncertainty is exactly what keeps it so compelling. Because every unknown is a future mission waiting to happen. And that mission is already on its way: NASA's Europa Clipper. It won't land. Instead, it will perform dozens of close flybys, using radar to peer beneath the ice, analyzing surface chemistry, and searching for organic traces in any plumes it can catch. Its goal is simple: to answer one question: does this frozen world actually have the conditions needed for life? If everything goes as planned, we may start getting clearer answers within the next decade. Until then, Europa stays silent. It doesn't speak, but it doesn't stay still either. And that leaves one final, bigger question hanging in the background. If oceans like this exist all across the solar system, maybe the reason we haven't found life isn't because it's rare. Maybe it's because we've been looking in the wrong way. As the saying goes, you don't find what you're not ready to recognize. Maybe the universe isn't empty. Maybe we just haven't learned how to knock on the right doors yet. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.